I'm going to start the next unit in the continuation with the first chapter, experimentation and measurement. Today I'm going to start the how we can estimate the size of the object, whether it will be given the smaller one or the bigger one. Okay, that means today I'm going to start the estimation of size by order of magnitude. In our daily life, the different types of objects we are getting. Some objects may be smaller one, and some object may be bigger one or larger one. Larger one maybe it will be larger than the mountain, and smaller than that means it may be more than the smaller than the dust. Okay, so that means we have to categorize in two ways. If once we are going to measure the larger object or smaller object, so we can categorize in two ways, and that two ways are as follows. Microcosm and macrocosm. Okay, microcosm and macrocosm. Microcosm, from the name it seems to be clear. Microcosm means that means we have to measure the smaller object. We have to measure the measurement in which we constitute the smaller object, that is called the microcosm. It's a Greek word formation. Micro means small. Okay, micro means small. That means the measurement in which we constitute the small object, that will be known as microcosm, and the object in which we are going to constitute the measurement of the bigger object or larger object, that is called the macrocosm. So there are two objects, there are two things, microcosm and macrocosm. Now come to the microcosm. Just going to take the example in microcosm, just like atoms, electrons, these things, then dust particle. That means the object that is we can't imagine this thing how much smaller that object will be. Similarly also we can take microcosm bigger than the mountain, just like going to take the example sun, the sun, the moon, the earth, okay, the planets. These things we can take the example of the bigger object. That means these objects are much bigger than the mountain, so it will be come into the category of the macrocosm. Okay, two types of categorization will be there: microcosm and macrocosm. Now suppose if we want to find the diameter of sun, it is given 1,390,000,000 meter. This is the diameter of the sun, it is given. If once we are going to read it, so it will be quite difficult for us to read this thing, to read this diameter. Okay, similarly if we are going to take the example of the smaller object, just going to take the example diameter of electrons. It is how much? 0.00000000106. This one meter. This is the diameter of the electron. Now if once we are going to read it, so it will be quite difficult for us to read this one. So for solve this problem, we have to write in two form, in the form of the numeric digit as well as into the form of numeric digit as well as in the form of uh, exponential form. So suppose if we want to write this thing, so we can write 1.39 into 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the power of 9 meter. That means if we are moving from right to left, if we are moving from right to left, so exponential form will be in positive. Okay, if we are moving from, again I'm telling this thing, if we are moving from right to left, so we have to write in the form of positive. Okay, now so this is the numeric form from 1 to 9, and this one is the exponential form, 10 to the power any 10 to the power of any number from 1 to 9 or 10 or any number, not only 1 to 9. This number will be 1 to 9, and this one exponential form, power any number we can write it, 100,000, anything can be there. Why it will be, if once we are going to write in this form, so it will be quite easier for us to solve the any problem. And if once we are going to write in this form, if we are going to write in this form, so it will be quite difficult to calculate any numerical problem, as well as if we are going to add it, if we are going to subtract it, if we are going to divide it. That means any type of calculation if we want to do by taking this thing, so it will be quite difficult for us to calculate it. Okay, so to solve this problem, we can write in this form. Okay, that is the numeric form as well as into the exponential form. Now it will, by using this concept, easily we can solve any numerical. Okay, now similarly if we are writing the diameter of the electron, how much given? 0.0000000000106 meter it is given. So if we want to write, so we can write 1.06 into, see, 1 2 3 4 5 6 7 8 9. Okay, how much is it? 10 to the power of minus 9. Again I'm telling this thing, if we are moving from right to left, okay, if we want to write in the form of exponential form, so if we are moving from right to left, so it will be right to left, it will be positive exponential form. That means 10 to the power of whatever the number if you are going to write it. Okay, if whatever the number if you are going to write it, it will be in the terms of positive. Similarly, if we are going in opposite manner, if you are going, suppose from left right to left, if we are going right to left, if we are going, and if we have to write it, so we have to write in the terms of exponential number. We have, that means 10 to the power, we have to write in the terms of negative. That means this one meter. Okay, that means on this basis we can write any number. Okay, and it will be also quite easier for us to solve any numerical problem if any numerical it is given. So by using this concept, by using this exponential form and numeric form, we can easily solve the numerical. Okay, now this is called the, whatever the number it is given, okay, the number that is given the exponential form, that is called the order of magnitude. This is called order of this is called the order of magnitude. Okay, so if anyone is going to ask what is the order of this one, so order of magnitude is 10 to the power of minus 9. Okay, some more things we are using in our daily life or in the physics for the calculation of the different types of a smaller object as well as the bigger object. I'm just going to take the example of some object, just like 1 micrometer, 10 to the power of minus 6 meter. 1 nanometer, 10 to the power of minus 9 meter. 1 angstrom, 10 to the power of minus 10 meter. Okay. 1 picometer, 10 to the power of minus 12 meter. Okay. Now come to the 1 kilo, 10 to the power of 3 gram. Okay. Now if we are going to take giga, 1 giga, so it will be 10 to the power of 9. 1 mega, so 10 to the power of 6. Okay, like these are the examples, some example by which we can show how we can write the order of magnitude of the different object for the measurement of the smaller object as well as the bigger object. Okay, okay. Now that means any number that will be given in the longer manner, or if any length is given very long, it is given, or if any number is given very small, too much decimal point, after decimal too much zeros are given, then we can write in the terms of numeric form, and it will be multiplied by exponential form. Again, I'm telling this thing, exponential form is known, if we are going to measure the any object, then the exponential form is known as, exponential form is called the order of magnitude. Exponential form is called order of magnitude. Now come to the next topic, degree of accuracy. What will be the degree of accuracy? Come to the next term, degree of accuracy. If we want to write any object, or if we are going to measure the any object, if we are going to write the length of any object, if we are going to write the volume of any object, then up to what extent without error, then we can say centimeter cube. And third one, you have got 1.3 centimeter cube. Okay, that means different times you are getting the different types of reading. That means first time you have got 1.003 centimeter cube, second time you have got 1.03 centimeter cube, and third time you have got 1.3 centimeter cube. So once we are going to calculate it, if once you are going to write the final result, once we are going to write the final result, so it will be quite difficult for us to write the final result, because every time we are getting the different result. So that means better write up to this extent. That means 0.1 centimeter cube, not 0.001 centimeter cube. It will be quite easier for you to solve the numerical problem also, as well as if for you to write in this form, that is not in this form, in this form. That means degree of accuracy is that one by which we can write the object result without any error. Okay, that means up to what extent we can write the any object without error. Okay, now come to the next one, percentage error. Okay, percentage error is that error in which we are going to calculate whatever the calculated value and whatever the actual value of the object is given. I'm just going to take the example. Suppose you have got the you have got the length of any object or 1.5 meter. Length is given 1.5 meter, and once you are going to measure it by meter scale, so it is getting something different. Okay, the length of the rod is given, or the length of the any rod or any object is given 1.5 meter, and after measuring it, its value is getting something different. Okay, that means suppose it's a given value, okay, and the after measured experimental value you are getting 1.3. That means after measuring it, you are getting something different. That means, see, given value is 1.5 meter, and the experimental value, that means once you are going to measure it, whatever the value it is given, it is correct or not, so it is getting something different. That means there is some error. Okay, that means whatever the length it is given and whatever the experimental value you have got, both are something different. And if once both are something different, so that means some error in the terms of percentage. That means how much percentage change in the given actual value. Again, I'm telling this thing, try to understand this one. If you want to calculate how much the percentage error in the given actual value, then easily you can calculate by using one formula. Percentage error equals to absolute error upon actual value multiplied by 100. Absolute error. Absolute error is the difference between the experimental given value difference difference of difference of experimental value. That means how much is the difference between the given value and the experimental value. By this one, by this way, we can calculate the absolute error. Absolute error is the difference between the actual value and the experimental value. That means how much the actual value is given, and after calculating, after measuring, how much you are getting the its value. So the difference of both one, the difference between the actual value and experimental value, keep this thing in mind, it's a difference. So it's a magnitude of both, the difference of magnitude both on that. That means it will never be in negative, always it will be positive, the difference between both one. So the difference between the actual value and experimental value, that will be the absolute error. And actual value, these, that means actual value means what the value is given. Actual value means what the value is given. Okay. So if once we are going to calculate on the basis of this one, so easily we can calculate. How we can calculate? See, the given value you have got 1.5 meter. Given value you have got 1.5 meter, and the experimental value you have got 1.3 meter. So if we want to calculate the percentage error, what the percentage error in the length, so easily we can calculate by using this formula, percentage error equals to absolute error. How much the difference between both one? 1.5 minus 1.3. 1.5 minus 1.3 divided by 1.5 multiplied by 100. So what will get? 0.2 upon 1.5 into 100. So calculate it. 2 by 15 into 100. Now 200 by 15, one time, then 1 0 0 6, this one. Okay, this much 10.6% is the error. Okay, 10.6% is the error in that one. That means easily we can calculate, if we want to calculate the error, easily we can calculate by using this formula. See, again I'm telling this thing, percentage error equals to 1.5 minus 1.3 upon 1.5 into 100. Then difference between both one, it is a 1.5. Okay. So 1.5 minus 1.3, you will get 0.2 multiplied by 100 upon 1.5. Now calculate it. Whatever the result you will get, that will be the percentage. And you have to write in plus minus both. Okay, maybe it will be plus. Plus, that means it is getting, that means gaining in the percentage error, and negative means it is getting loss. Okay, so by this way we can calculate the percentage error. In the higher class, in the class 12, you will get the some more elaborate manner, some more expand will be there. But right now you must be knowing these things, how we can calculate the percentage error of the given object. Now one more example I am going to take it. Suppose you have taken the temperature, or suppose you have taken the resistance of any object, resistance of any wire, you have got resistance of wire. Two point 2.3 ohm. 2.3 ohm, because some students are not knowing the symbol, so better writing ohm. Okay, symbol of ohm is, resistance symbol is this one. And this is the resistance of the wire. After measuring it, we are getting, and the actual resistance it is given, 2.0 centimeter, suppose 2.0 ohm. Okay, this is the resistance of the wire, that is we have got experimental, and this is the actual resistance. That means the resistance of the wire that is given. Okay, that means this is the below one is the given resistance, and the above one is the resistance of the wire, that is experimentally we have got what is the exact resistance of the given wire. So we are getting 2.3 ohm, and this one is the actual resistance. Now if we want to calculate the percentage error, so easily we can calculate the percentage error on the basis of the both the things. That means percentage error, already given the formula, absolute error upon actual value multiplied by 100. This is the formula by which we can calculate the percentage error. Now already I have explained previously How we can calculate the absolute error? Absolute error is the difference between the actual value and experimental value. Below one is the experimental given value, given resistance 2.2 ohm, and this one is the experimental value. You have got 2.3 ohm. Okay, this one is the experimental value and this one is the actual value. Now the difference between both one, that can be taken as the absolute error. So absolute error, what you will get difference between both one? 0.3, and below one what you will get? 2.0 multiplied by 100. Now calculate it. Whatever the result you will get, that will be percentage error. Okay, that means by this way we can calculate the percentage error of any object. Okay, because in our daily life we are getting the different types of object, and if once we are getting the different types of objects, so possibility of error will be also there. Okay, possibility of error will be also there. So by is if we are knowing the experimental value and if we are knowing the actual value, then easily we can calculate the percentage error of the given object. Easily we can calculate. Okay, now come to the next topic, that is the significant figure. Now some more problems on the basis of the percentage error already given in the textbook. So by using the textbook, you can solve some practice problems, some numerical problem also you can solve by using this formula. Higher class you will get some more problems you will get. Okay, but right now try to solve the practice problem that is given in your book. One problem already I have explained. I think 2 or 3 more problems will be given in your book, so try to solve that one. Now come to the next topic, significant figure. Okay, significant figure, that means if once we are going to do the experiment and if we are going to do the calculation, so we can write the any reading up to what digit we can write, up to what decimal point we have to write, and it depends upon the two things. First one, nature of the experiment, first thing, and second thing, the accuracy. That means the number that or the readings that you are going to take, up to what accurate manner you are going to take it. Okay, so significant figure depends upon the two factors. Significant figure depends upon the two factors. First one, nature of the experiment. Okay, first one, nature of the experiment, and second one is the accuracy. That means up to what accurate manner the given number, the given reading can be written. Okay, now I'm going to take the example. By the example, these things can be easily explained. I'm just going to take an example. Now, the acceleration due to gravity. Acceleration due to gravity. The value of g. The value of g, it is getting 980.64. Suppose you are getting centimeter per second square. Okay, you are getting acceleration due to gravity 980 the value of G you are getting 980.64 centimeter per second square. This thing you have got, the acceleration due to gravity, okay, of the given bob you have got. Okay, now if you want to write it, so you can write also in this way, 9.8 into 10 to the power of 2 centimeter per second square. Okay, you can also write 9.80 into 10 to the power of 2 centimeter per second square. And third one, you can also write 9.806 into 10 to the power of 2 centimeter. All things you can write it, but the degree of accuracy in this one, the degree of accuracy in the first one, it is in between 1 to 10. See, degree of accuracy depends upon this number. Up to what decimal point you have written the number? 9.8 I have written. So 9.8 written, that means up to one decimal point I have written. So the degree of accuracy, it will lie in between the 1 to 10. This is the degree of accuracy. This is called the degree of accuracy. I am going to write here. Degree of accuracy. Degree of accuracy, if we are going to write 9.8, that means degree of accuracy 1 to 10. Here in this one, degree of accuracy 1 to 100. Why will be 1 to 100? See, up to 2 decimal point I have written it. So if once we are going to write up to 2 decimal point, so the degree of accuracy, it will be increased. That means 2 decimal point 100, 1 decimal point 10. Now here the degree of accuracy what will be? Because we have written up to 3 decimal point. Okay, we have written that up to 3 decimal points, so it will be degree of accuracy in between 1 to 1000. Okay, by this way we can write the degree of accuracy as well as into the number. Okay, till here I think everything is clear. Now see this one once and try to see this one up to in what manner nature of the experiment means. See, the nature of the experiment. Nature of the experiment means if once we are going to write it, so what the object you are going to measure it. Acceleration due to gravity, basically it is going to measure up to 1 decimal point better. Then up to what 1 decimal point you can write it. Now in the same way also, if once we are going to write it, accuracy means up to what decimal point if you are going to write it. I have already given the example in if the 9.8 into 10 to the power of 2, that means up to 1 decimal point. Degree of accuracy is up to 1 decimal point you have written, so degree of accuracy in between 1 to 10. Similarly, if you are going to write the 9.80, that means degree of accuracy in between 1 to 100. In the same way also, if you are going to write 9.806, that means degree of accuracy till in between 1 to 1000, because we have written over here up to 3 decimal points. So if once we are going to write up to 3 decimal point, so degree of accuracy will be also changed. Now come to the next topic. The next topic I am going to explain in the continuation with the measurement and experimentation. Same thing. If once we are going to measure any object, so 2 things we can calculate it. Okay, 2 things we can calculate it. First thing, by the use of the meter scale, we can find out the use of the meter scale. We can find out the length of the any object, and that meter scale, it will be consist of 100 divisions. That will be 1 meter equal to 100 centimeter. In the same way also, if we are going to calculate the smaller thing, So again the centimeter will divide into millimeter. Okay, again I am going to explain it. If once we are going to measure the length of any object, so by the use of the meter scale we can easily calculate the length of any object. Okay, and that meter scale again it will be consist of 100 division. So 1 meter equal to 100 centimeter. Similarly, if we are going to again going to divide it, so that means if we want to measure the, if smaller than the meter, centimeter, smaller than the centimeter, smaller than the centimeter, millimeter, smaller than meter, centimeter, smaller than centimeter, millimeter.